All right, let's talk about a hidden threat, a really big one, lurking right at the heart of our power grid. It's a story about these invisible giants, and believe it or not, a simple, everyday material that's pretty much the only thing keeping our world from going completely dark. So, yeah, let's dive right in.
Okay, so first up, let's talk about the massive kind of unseen machinery that powers, well, everything in our lives. We're talking about the real unsung giants of our entire infrastructure.
So let me ask you this. What do you think is the most expensive, most strategically important machine that you almost certainly never see? And no, it's not some fancy supercomputer or a top secret satellite. The answer is actually hiding in plain sight, scattered all across the country.
It's this thing right here, the Large Power Transformer, or LPT for short. You gotta understand, these things are the absolute cornerstones of our high-voltage electrical grid. Think of them like massive metal hearts, pumping electricity across the entire country, making everything you do, well, possible.
And listen, the stakes here, they could not be higher. When one of these giants goes down, it's not just a small hiccup. We're talking about a potential breakdown of the insulation inside, which can lead to huge financial losses and major disruptions to the power supply. So yeah, keeping these things healthy isn't just a good idea, it's a massive economic priority.
And this is where it gets really interesting. Kind of paradoxical, actually. The key to protecting these multi-million-dollar machines, it's not some futuristic high-tech alloy or some super complex chemical. Nope. It's something way simpler.
You heard that right. Inside these massive, high-tech, high-voltage metal boxes, the single most critical component is paper. Just humble paper. Now, it's a special electrical-grade paper made from wood pulp, but still, it's what's used to insulate all the critical wiring deep inside the transformer.
So why paper? I mean, it sounds crazy, right? Well, it all comes down to a little thing called cellulose. Cellulose is basically these long chains of glucose rings you find in wood, and it just so happens to have incredible electrical properties. It's a fantastic natural insulator, which makes it absolutely perfect for handling the insane electrical stresses happening inside a transformer.
And just to be clear, we're not talking about your everyday printer paper here. This stuff is made through a really specific process. First, you take wood fibers, turn them into pulp. Then, that pulp gets washed, cleaned up, and laid out into a sheet. Finally, it gets pressed and dried with these big, heated rollers to make sure it's perfectly smooth and has just the right thickness. That's how you get the perfect insulator.
But what happens when this perfect insulator starts to, well, not be so perfect anymore? This is exactly where that hidden threat we talked about comes into play.
The biggest, baddest enemy of this paper insulation is something ridiculously simple: moisture, water. Over time, even the tiniest little bit of water seeping into the system can cause that paper to just break down. It gets weaker, it can't insulate as well, and that sets the stage for a total catastrophic failure.
And look, this isn't just some theory, it's a real-world problem. Get this, research has shown that the average age of these huge power transformers that failed because their insulation broke down was just 18 years. 18! When you consider these things are supposed to last for decades, you can see why that's a massive and very expensive problem. So, okay, if you can't even see the problem, how in the world do you fix it? Well, that's a great question, and engineers have actually developed a whole field of science dedicated to basically giving these giants a regular health checkup. And that right there is the big challenge. I mean, this paper insulation is sealed deep inside the transformer, completely soaked in oil. You can't just pop the hood and take a peek. You have to figure out a way to diagnose what's going on from the outside. And to do that, they've come up with a seriously impressive toolkit. I mean, we're talking about everything from analyzing gases that have dissolved in the transformer's oil to using acoustic sensors to literally listen for problems. They even test for these tiny electrical sparks called partial discharges. The list just keeps going, as you can see here.
But among all these different techniques, one has really risen to the top as the best way to figure out what's happening with the paper itself. You can almost think of it as a way of listening to the electricity. And the star of this particular show is called the dielectric response method. Right now, this is pretty much the most sophisticated and reliable way we have to check on the two most important things for a transformer's health: how dry that insulation is and how much it's aged over time.
Now, it's a super powerful tool. but it's not a silver bullet. The big plus is it's crazy accurate when it comes to measuring moisture, and it works really well on older transformers, which, saves a ton of money by stopping outages before they happen. The flip side is it can't totally replace an internal inspection. And for certain kinds of checks, other on-site methods might still be the way to go.
So how does this theme actually work? Well, in a nutshell, scientists are measuring the electrical properties of the insulation. This symbol you see here, this represents DC conductivity. Basically, by measuring how easily a direct current can flow through the insulation, they can figure out its condition and how much moisture is in there. It's really like taking the transformer's pulse. Another really key measurement they take is called permittivity, which is what this symbol represents. This one tells scientists how the insulation material stores up energy when it's hit with an electric field. And if that permittivity starts to change, well, that's a big red flag that the paper is getting old or has soaked up some moisture.
Okay, so let's tie all of this together. Why does any of this matter? Why do we care so much about diagnosing the health of some paper inside a giant metal box? Well, it boils down to one simple thing: keeping the lights on. At the end of the day, these advanced diagnostic tools matter to every single one of us. They cut down on those unexpected failures and sudden power outages. They let the utility companies do planned, smart maintenance instead of scrambling to fix emergencies. And all of that improves the reliability of the entire grid, making sure we all have a steady, continuous supply of power. It's literally the reason your lights turn on when you flip that switch. So the next time you flip a light switch, maybe give a little thought to that humble piece of paper, working its magic deep inside a transformer somewhere down the line. And it kind of leaves you with a final question to chew on, right? What other invisible materials, just like this special paper, are out there quietly holding our modern world together?